Good morning, my dear kids. In today's class, in the topic, in the chapter optics, in the prism topic prism, we'll discuss some problems on the prism. So, if you can recollect in the past two classes of the prism, we had a theoretical discussion. We discussed all the theory. So now we'll focus on the problems here. So first, let me begin with a problem strategy. Like, what should be the methodology that should be involved in solving the prism problem? We'll have analysis. Then we'll explore the different types of numericals. So this prism is again nothing but the application of Snell's law, refraction at plane surface. There in the plane surface, we had the boundary. Here the boundary is defined by the two faces of a prism. So it's like in the slab, what we discussed now, the two faces are parallel. Here, the two faces are not parallel. So hope at least after doing working so many numericals, students should analyze that the basic idea is the Snell's law. That has to be applied everywhere here also. So let me start the class. So first we'll begin with the how to solve prism problems. So the main theme here will be drawing the ray diagram. So if you are good in ray diagram, it will be very easy for you to analyze the prism problems. Ray diagram means let the ray be incident to any direction and any circumstance that happens. So what will happen to emergent ray? So first, finally, there's a prism. So we have different types of prisms already. We have come across equilateral prisms, right angle prism, triangular prisms, yeah, like a isosceles prisms. Then we had different prisms also. So let's start with the thing. A ray is incident here. Then what will happen is like here. There's a normal. Draw the normal. Then we know that the ray is moving from rarer to denser medium. So the ray should bend towards normal. Okay, there's a rarer medium, there's a normal. Then again, here you draw a normal. Now the ray is moving from denser to rarer medium. So it should bend away from normal. Okay, away from normal. This angle of prism. Okay, later on we'll write all some equation. The first, what will happen to the ray when it passes through the prism? What will happen to the ray? So this is the background is what we needed. Okay. Next after this, now if a ray is incident at certain angle, then after refraction it becomes parallel. Then this will be minimum deviation. These two angles will be equal. These two angles will be equal. We know this one. So this particular thing is minimum it's a minimum deviation condition it is. Sir, how do you can say like this? What see? I'm once again I'm insisting that the ray after refraction, we have to just apply the law here. The Snell's law is what the basic condition here. Huh? Okay, now here the ray is incident. I'll draw the rough diagram. Then there's an incident ray. It can come anyway, no? The ray need not be always like this. The ray may come like this here. So this is the normal. Then after reflection, I'll better take it off. Oh. Will come like this. So, sir, what you are doing here, like, okay, now this was the incident ray. So it will undergo the ray moving from right to denser, it will bend towards normal, so the ray will be incident here. Here the ray will undergo TIR. Here moving from denser to rarer medium, so the ray will finally emerge here. If it doesn't undergo TIR, what will happen? If it doesn't undergo TIR, where the angle of incidence is greater than critical angle, so it's undergoing TIR. If it doesn't undergo TIR, then we'll get a situation of like this. Then the ray, you look at this one here, rarer to denser will bend towards normal. Again, this is normal. Denser to should bend away from normal, away from normal. Okay, fine. So you just, these are small ideas a student has to start himself. Now is next situation, a ray is incident. Now it happens that we know it will undergo diffraction. Then if it is incident normally, it will go undeviated. Here, yes, this is very important. It is incident at 90 degrees. Sorry, angle of incidence will be zero. Here the ray is incident will undergo diffraction. It is moving from rarer to denser. Then if it is incident normally here, normally in the sense angle of incidence will be zero. Then it will not undergo refraction here. It will just emerge out here. It can happen. Huh? This can also happen. So next condition. The situations will be given for you. Huh? Okay, now the next one, the ray is incident here. So here it will be, no, if it undergoes TIR here, we know if TIR occurs, it will be reflected symmetrically. Then again draw a normal. It all depends upon the given conditions. Huh? Now here TIR occurs, so previous problem. Anything can happen. If it is a minimum deviation, it should be parallel to the base. This is the base. TIR occurs here. If TIR occurs, it will get reflected. So what we have to do is like, is there any TIR is occurring? So all that conditions is what we have to check it. I brought next here. So if a ray is incident here, so the ray here angle of incidence zero, angle of refraction zero. So the ray goes undeviated. Here it will undergo refraction. Moving from denser to rarer, this is a normal, so it should bend instead of traversing straight. What happens? It will bend away from normal. Now a situation. The ray, if it undergoes TIR here TIR, I'm putting that one. Sir, how do you say it will undergo TIR, will not undergo TIR? The conditions will be given for us. Okay, no? You need to bother. So the ray will get reflected. Okay, fine. And now if a ray is incident, this is a normal. If a ray is incident like this, instead of incident, normal incidence, then let's analyze here. The ray moving from rare to denser, so should bend towards normal. So towards normal. Okay, done. Then again it's moving from denser to rarer. So let's go for the normal. There's a normal. Then the ray will be in this direction. Ray moving from rarer to denser. So the refracted ray should bend towards normal. There's the incident angle. This incident angle is less than critical angle here. It will undergo refraction, so it will emerge out here. Anything can happen. I think you can manage, you know. Next again, if a ray is incident, hmm? Okay. But sir, I am not seeing any prism. Let it be. This part is what you can treat like a prism. This will be the angle of prism. Work out, take help of all mathematics. Next again, if there are more than one prisms are there, so that the ray let it be incident here, undergo refraction. Let it be. Are you getting now? If there are multiple prisms are there, so the ray will start from here. Now will undergo again further refraction. So what prism? It just deviates. It changes the path of the ray. That's what I mean to say. Not only one prism. If there are multiple prisms are there, you can bring the concept like this. Due to this particular prism, there will be deviation. Again, the ray will further undergo deviation due to this prism. Now calculate deviation of this. That will be the net deviation. If it undergoes TIR here, if it undergoes TIR, so it will come out like this. Okay, getting idea now. So this about the student. What you should do is like first you should you should not go for problems. Huh? So first take the different shape prism. Let the ray strike the prism in a different directions at different phases. Then what will happen to the ray? So somewhere whenever a ray moving from denser to rarer, there is a possibility of TR. If there is a TR, if there is no TR, then what conditions will arise? So in this way, one has to analyze. So this a background is what needed for us. Okay. Okay, let's start with the small numericals. So it's telling this the first question. By what angle the mirror should be rotated for the ray to retrace its path after reflection from mirror? Yeah. So there's a ray is incident here. So they look at the angle 2 degrees mu. So it's a small angle prism. So what is the expression for deviation for small angle prism? This should be equal to mu minus 1 into A. Mu is 1.5 minus 1 into A is how much? 2 degrees. So 1 degree is what? The deviation. So the net deviation produced by this prism will be 1 degree. So instead of, if the prism were not there, the ray would have just traversed horizontally. Now this particular prism, what it does, it will produce. So now definitely the ray is not incident normally on the, I'll choose some color. You can see that the angle of incidence theta, there's a deviation, there's a deviation, there's a deviation. This is a mirror. So what is the question that is asked? By how much the mirror should be rotated so that it should retrace the path here. So what has to be done? Now let me take help of the situation here. Now it has to retrace the path. So I'll take it out this path. So the mirror should be rotated, no? So through what angle the mirror should be rotated? If it is incident normally, if it is incident normally, then only retrace is possible. Then how much the reflected ray should be rotated by 2 degrees? Then how much mirror should be rotated? How much the mirror should be rotated? So you recollect the concept here. So what concept, like if a mirror is rotated by, if a mirror is rotated by theta, the reflected ray will rotate by 2 theta. So what is the angle through which the reflected ray should rotate? 2 degrees. So the mirror should be rotated by 1 degree. So what should be the angle now? So the angle, I should rotate the mirror by 1 degree. Then the reflected ray will rotate by 2 degrees. So it will retrace a path. So the mirror must be rotated angle 1 degree so that so that the reflected ray rotates by 2 degree and hence can and hence it can retrace the path. The ray now will be incident normally, it will retrace the path here. Okay, hope. Small angle prism. That's why we are using that particular formula. Yeah, next problem. The path of ray of light passing through an equilateral prism ABC, there's a prism is there, is as shown. The ray of light is first incident on the face AB, then undergo TIR at face BC and emerges out from the face AC. Okay, the net deviation produced by the prism is 108 degrees. This is incident ray, this is emergent ray. You have to calculate the refractive index of material of the prism. He has given some information, sine 24 is equal to 0.4 degrees. Okay, let's start with this is a normal, this is a normal, this is a normal. Okay, agreed. So let this be the angle of incidence, I1. This will be R1, R2, R2. Let this be R3. Let this be I3. So deviation, it will and it will undergo TIR here. Here undergoes TIR. So if it undergoes TIR, it will act like a reflecting surface. Angle of incidence should be equal to angle of reflection. Now we have to calculate the mu of a prism. Now what will be the approach? Way to bring the mu. Okay, let's get into some relationship between the angles. Now, it's a equilateral prism, so therefore this angle 60 degrees, 60 degrees, 60 degrees. Then if you equate the so carefully, so let me expand the diagram. You can see all the things. So this angle, let it be alpha. So now, are you seeing this one cyclic quadrilateral? M, B, N, say some symbol here. Then also one more cyclic quadrilateral, O, C, N, and this particular point. So in cyclic quadrilateral, the sum of opposite angles should be 180. So 60 plus, there's a solution, 60 degrees, some cyclic quadrilateral. So 60 degree plus alpha equal to 180. So alpha is equal to how much? 60, 120 degrees. Then from the triangle, this triangle, and some symbol I'm unable to write it because the space is not there, and you call say some P M in this triangle. Sum of angles will be R1 plus R2 plus alpha equal to 180 degrees. Alpha is 120. Similarly, in the quadrilateral, 60 plus beta equal to 180 degrees, beta equal to 120 degrees. Then triangle, here, this cyclic quadrilateral. Sum of opposite angles should be 180. Then in this triangle, beta plus R3 plus R2. So therefore, equating these two, from 192 what we can write, R1 equal to R3. If R1 equal to R3, then sine I1 equal to mu sine R1. So therefore, I1 is also equal to I3. Okay, these are some important conclusions we have. Okay, then let's take help of this deviation. So the net deviation should be equal to deviation at M and O. The total deviation suffered by the ray at M and O should be equal to sum of deviation at M and O. So the net deviation at M will be I1 minus R1. Deviation here, this is the angle. The ray wanted to, incident ray wanted to go straight if there were no prism. But due to refraction at M, it took path like this. So what is the deviation? I minus R1. If a ray moves from brighter to denser, the deviation will be angle of incidence minus angle of refraction. Then it wanted to traverse path like this. So it got reflected. So this is the deviation, 180 minus 2R2. Deviation at O. So the ray moving from denser to rarer, then angle of refraction minus angle of emergence should be the deviating angle. So this will be R3 minus R2. We know R1 is equal to R3, I1 equal to I3. So 2I1 minus 2R1 plus 180 degrees, or say 2R2 minus plus 180 degrees minus 2R2. R1 equal to R3. Yeah? It will cancel out. This will not be there. Since R1 equal to R3, so minus 2R2 plus 180. R1 equal to R3. R1 equal to minus R1 plus R3 will cancel out. Minus 2R2, 180. So I1 equal to I3 will get here. We know what is other information is asking to get the material of the prism. How to solve further. So some I1 and so we will take help of this condition. R1 plus R2 equal to 60 degrees. So here R1 equal to 60 minus R2. Here looking at this one. Already we had no R1 plus R2 60 degrees. So let me take sine on both sides. Sine R1. Okay, let it be here. Sine R2 should be equal to 1 by mu. From where I brought this equation? Because the ray will undergo TIR here. So sine of critical angle should be equal to 1 by mu. Okay, this equation I brought it. Now we have to get expression for mu. So mu will come sine I1 equal to mu sine R1. So I should replace R2, I got it. Okay, let me take help of this equation. So sine R1, yes, let me explain now. Sine R1 equal to sine 60 cos R2 minus, so sine R1 equal to root 3 by 2. Cos R2 will be root of, I will write it somewhere here. It will, and I'll scroll down. We'll move further. This is one part of discussion. Let me continue. Sine R1, sine R1 equal to sine of 60 minus R2. Expanding this, sine 60 cos R2 sine R2. Then this will be cos R2, so this will be 1 by 2. Sine R2 is 1 by mu. So sine R1 equal to root 3 by 2. Okay. But we wanted mu, no? Okay, somewhere we have reached mu. Sine I1 deviation we know. So I1 and R2. So somehow I think I should get the. We have information of R1 plus R2, no? Yes. I1 is needed, no? I1, can I find out? R2, I need a lot of place here. Yeah. We have to calculate this I1. Huh? Oh, 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 oh. I will rewrite this. I1. This will be R1 plus R2 plus 180. This one R2 I'll split up. R2 plus 1, R1 plus R2 is 1. Another R2 and R3. Minus R2 plus R3. Here, this went from I3 minus R3. Oh, okay, no. Angle of emergence minus angle of incidence. That should be. So I1 equal to I3. So 2I1. So one R1 and R2. R1 plus R2. Other R2 and R3. We'll get here. Okay, fine. 2I1. R1 plus R2 is 60 plus 180 R2 plus R3 is also 60. Deviation how much given? 108 degrees. 108 degrees to I1. This will be 60 degrees plus 60 degrees. 48, 24. So I1 equal to 24 degrees. After getting I1, now R1 is needed. Okay, fine. So much of calculation. I don't have place here. I'll come back to this equation. So this will be sine R1 root 3 by 2 mu square by minus 1 minus 2 mu. Then we'll apply the Snell's law. Sine I1 equal to mu sine I1. Sine I1 sine 24 degrees equal to mu. So solving this, here mu will get cancelled. Sine 24 degrees we know. So solving will get the mu. I need place. I'll just think so. Okay. Let me this. Yeah, okay. Now we have. Yeah, I can show all the things now. So sine 24 degrees equal to root 3 by 2. Solving now. Mu is only unknown thing. So I think if you see the breakup here, this part, something relationship between the angles. Let me shade it. This is some relationship between the angles. Okay, this is all about the deviation one. You see, the problem is very beautiful, where the student has to apply so many concepts. That's why I just picked up this problem. Okay, this is about the deviation one. What is the deviation thing? When a ray moves from rare to denser, angle of incidence minus angle of refraction. It gets reflected. So 180 minus 2R2. When a ray moves from denser to rarer, angle of emergence minus angle of refraction. Now this R1 plus 1 minus R1 minus R2. Minus R2 minus R3. It is adjusted. R2 plus R3 again we have here. 60 degrees. R1 plus R2 60 degrees. That is substituted here. Okay. Solving will get I1. Then this is about the other part. From where this is brought, sine R1 equal to, again I took help of this equation. R1 plus R2 60 degrees. So R2 R1 is equal to 60 minus R2. I'll apply sine on both sides. Then we have started here. Hope I'll bring all the things. Yeah, you will not get confused at least. screen, I have very less space on the screen. That's why. Oh, yeah, you have everything at one place. Huh? So solving this will get expression from you. Calculation, I will leave it to student. The mu value is what I'll give it. You check it. Huh? At least you have to do calculation part. Don't ask teacher to solve this also. 1.447. This will be our answer. Hmm? Able to understand? So whenever the prism problem comes, so you focus more on things like this. Huh? Okay, see one complete view. Then I'll go to the next problem. Read this question. Okay, ray of light is incident on the face AB. AB refracts and is incident on the critical angle at face AC. And finally emerges out from the face BC as shown. Find the refractive index of prism and angle of incidence. You have to calculate the mu and this one. This is equilateral prism. He has given this angle. Now, again, the higher approach would be same. Let this be R1, R2, R3. These are the angles. Now this R1 plus R2 should be equal to 60. Already we have worked out. Huh? So sir, not understanding. Okay, I'll no, these two will, this will make an equilateral, so like a cyclic quadrilateral. This angle and this angle should be 180 and we'll get a one triangle. So from there, what we get is like, I'll write down this alpha, this beta, this is P1, this is P2. From cyclic quadrilateral, so this is N, LMN, we'll use instead of. So ALP1M in the quadrilateral, ALP1M alpha plus 60 equal to 180 degrees. Then in the triangle LP1M, I'll increase the font size. So alpha plus R1 plus R2 should be equal to 180 degrees. So from here, similarly, quadrilateral CMP2N, this should be equal to beta plus 60 equal to 180 degrees. So triangle MPN, this should be equal to 180 degrees. So solving all this, again we'll get it as R2 plus R3 equal to 60 degrees. Okay, now we have this relationship. So now find the refractive index of the prism emerges out from the face BC. So here it will undergo. So now let's write some equation like sine I1 mu sine R1. So here we have to calculate the refractive index of material of the prism. So we don't have any further information of like the total deviation. All that information is not available like previous problem. Check it. If you want to can calculate, but that information is not available for us. We have to calculate the refractive index and angle of incidence. Only this information is available. Is it R1 equal to R3? Comparing these two. Yes, R1 equal to R3. If R1 equal to R3, then sin I1 equal to mu sin R1. Mu, therefore, I is equal to 35 degrees. This just only by comparing things I brought expression for angle of incidence. Now we have to calculate the mu of a prism. That will let me take help of at n. I'll apply Snell's law at n. Mu sine R3 mu is what we needed, sine 35 degrees by sine R3. Sine 35, I think, let me check with the calculator. Zero 0.57. Sine 35 degrees, so 0.57 sine R3, sine of 60 minus R2, I'll write it. This will expand cos R2, I'll write it as so it undergoes TIR, no? Undergo TIR. So if it undergoes TIR, sine R2, I can write it as 1 by mu. So this will become root 3 by 2, 1 minus 1 by mu square. Mu root 3 by 2 mu square minus 1 by 2 equal to 0.57. How do this equation came? The denominator I'll send it to the numerator. The denominator in the RHS I'll send it to the numerator in LHS. Okay, this mu square minus 1. So 1 by mu square under root will be 1 by mu. It will get eliminated. We get so solving. I'll get the mu value. 1.58. This will be your answer. Okay, check it again. The method is same. Where all TIR comes, you see the formula of the sine of critical angle equal to 1 by mu. The reason for that we are using is like the other medium is air. I need not to mention that. Okay, this is air, no? Usually we do all our experiments in a room, in in air itself. So surrounding medium by default will be air. If it is other than air, I'll mention it. Okay. Again the same first relationship between angles, then applying Snell's law. So then the idea of TIR. Let's read the question. The diagonal AC of right angle prism is silvered. A ray of light falls on face AB and finally emerges out from face BC. Find the angle phi made by the emergent ray with the normal at the face BC. I think some diagram. There's a normal I'm doing it. It may not appear normal. Okay, let it be normal. This angle is what we have to calculate. Some small correction. Let me draw it properly. Yeah, fine. So it is striking. First, it will strike the face AB. So this is a normal. So this angle 30. So this should be 60 degrees. Let's do the analysis. If you extend this, how much this angle will be? 60 degrees, 90. This will be 30. This will be 30. This will be 60. This is R1, R2, R2, R3. Yeah, fine. So this angle will be 30 degrees. We have to calculate just that particular angle. Mu equal to 1.5. Again, same thing, R1 plus R2, 60 degrees. Then one more equation, R1, R2 plus R3 equal to 30 degrees. This is silvered. Huh? how to calculate this angle phi. So we have mu of a prism also. Where is the prism? This is the prism. Huh? This everything is a prism. Fine. Now get into the what we have to do. We have to write first relationship between the angles. Already I brought some angles. Okay, now first sine 60 equal to mu sine r1. Yeah, this one. Sine 60 equal to mu sine r1. There's a one equation we are writing. Similarly, mu sine r3 equal to this particular angle. Mu sine of r3 equal to sine phi. Mu value we know. So I'll get the r1 value. So root 3 by 2, 3 by 2 sine of r1. So sine of r1 equal to 1 by root 3. Very, I should, let me check with the calculator. R1 equal to sine inverse of 1 by root 3. R1 equal to how much it will be? I had to calculate it. There's no other way. We have to use the scientific calculator, or else in the exam they will mention. You know to bother. So this will be R1 equal to 35.3 degrees. So we know R1 plus R2 60 degrees. Then this will be 35.3 degrees equal to 60 degrees. So R2 is equal to how much? 24.7 degrees. Then we know R2 plus R3 equal to 30 degrees. We'll get R3 as how much will get? 24.7, 5.3. This value I'll substitute here. Mu is how much? 3 by 2 sine of 5.3 degrees. Solving this, I'll end up with this will be your answer. Again, check once the way of writing equations here. So whenever you get a prism problem, first trace out the ray. What will happen to the ray? It will undergo refraction, or will get reflected, will undergo TIR, and how it will emerge. Then look at the prism angles. Then angle of incidence, angle of refraction. Those things you mentioned. Then get relationship between these angles. Then apply Snell's law. Anyway, TIR, take help of TIR. I think that this is the way of solving problems what you might have. Okay, let's take the next one. We don't have a diagram. Sometimes they don't give diagram. From the data, looking at the data, you are supposed to bring the diagram, then after getting the diagram, then draw the ray diagram. From ray diagram, then you should start analyzing. Okay, that's three. A ray of light is incident at an angle of theta on one face of prism having reflecting angle. So I should draw a prism first. Okay, let's draw a prism. First you draw prism. See, anything drawing prism is something very important. First we'll draw the prism. So what is telling now? A ray of light is incident at an angle of 60 degree on the face of a prism having refracting angle 30 degrees. This angle is 30 degrees. The ray emerges out of prism making an angle 30 degree with the incident ray. Show that the emergent ray is perpendicular to face through which it emerges and find mu. Mu of prism here to calculate. Okay, the ray is incident here. So this is the 60 degrees. We don't know this R1. This is R2. This is say some theta. And the ray emerges would be making an angle 30 degree with the incident ray. So the deviation total is 30 degrees. So what is the, I think I'll write symbol. Again, same problem. Let's get into I2, this I1. So what is the deviation? The deviation equal to I1 plus I2 minus A. This is A. The ray emerges out of prism making a 30 degree with the incident ray. This is 30 degrees. I1 60. I2 we don't know. Angle of prism, refracting angle 30 degrees. I2 0. If I2 0, then R2 0. With this is asking to calculate the prism. So sine I1 equal to mu sine R1. We know R1 plus R2 is equal to A 0 and this is 30 degree. R1 is 30 degrees. Sine 60 equal to mu. So this will be the mu of a prism. We'll take the next problem. In a 60-degree angle prism with mu equal to 1, the condition for minimum deviation is fulfilled. So this, what is the condition? So if there's a base, we know at minimum deviation the refracted ray will be parallel to the base. Okay, then let's directly get into the, let's read the question. In a 60-degree angle prism with mu equal to 1.5, the condition for minimum deviation is fulfilled. If face AC is silvered, find the net deviation. First minimum deviation is there. Now I'm going to silver it. Then he'll ask you the deviation. Then he'll immerse this in water. Then he'll ask deviation. So all three parts are there. They're the first part of the problem. So we'll calculate these angles now. This is I1, R1, R2. We know at minimum deviation I1 should be equal to I2 and R1 equal to R2. R1 plus R condition is, and we have one more, R1 plus R2 equal to A. So can we get I1? Sin I1 equal to mu sin R1. Mu is how much? 3 by 2 sin 30 degrees. So I1 will get the 37 degrees is what will get the I1 value. Three by four, 48. Sorry, 48. I took calculator using scientific calculator. I'm able to predict this value. Okay, keep this I1. Okay, next is asking. Now if face AC is silvered, find the net deviation. This is one part of the question. If face AC is silvered, find the net deviation. Say under same circumstance, only the face AC will be silvered. This angle is 60 degrees. Degree angle prism. So this angle will also be 60, 60. So first we'll write all this data. This side is silvered. Okay, fine. So now it will be, so that the angles incident is same. There won't be change. I1. This will be R1. It's a mirror R2, R3. This will be I3. So what are the relationships now? R2 plus R3 should be equal to 60. R2 plus R3 should be equal to 60 degrees. So, yes, yeah. R2 plus R3 should be equal to 60 degrees. R1 plus R2 is 60 degrees. We know R1 30 degrees. So we know R2 is also 30 degrees. So as we know, I'll write it here. 30 equal to, therefore R3 equal to 30 degrees. And we know R2 plus R3, we got it. So we'll calculate I3 now. Now mu sin R3 is equal to, mu is how much? 3 by 2 sine 30 sine I3. So we have to calculate again. I3 will be 48 point. This is very important. These two angles will be same. Hmm? Okay, now he's asking deviation. Deviation L, M, N. The net deviation should be equal to deviation at L, M plus N. Deviation at L, I1 minus R1. Deviation at M, here. Angle of incidence minus angle of reflection. Deviation will be 180 minus 2R2. Deviation at N, angle of refraction minus angle of incidence. I1 equal to I3, we have 2I1. So we know R1 plus R2 is 60, no? 60 degrees. R2 plus R3 is also 60 degrees. Negative sign. So solving this, we'll get the deviation. 2I1, I1 48, no? So 48.6 degrees. So net deviation, we'll get it as 157. 48, 48, how much will be? 106, 107, 157. Okay, this will be your answer. Next again, if it is same thing, if it is immersed in water, all the relationship will remain same. Only thing is that I1, I3, everything we have to, the angle of incidence will be same. I think the Snell's law here will change. Here it will change, no? Sine I1. So here mu W sine I1 equal to mu sine R1. The next part of the problem. Find the net deviation. Now the prism is immersed in water. Find the corresponding net deviation is asking. Uh-huh. So here then what we'll do is like mu will get added up here. This I3 will change. Okay, we have to go for the next part of the problem. I have to immerse in water, no? The prism, now I'll bring the prism. and the same silver conditions will be there. Okay, the ray will be incident. The same angle I1, R1. The angle will not change, only here R2, R3. This angle will change. I'll write theta. I1 will be as it is, huh? Mu W it is. So the net deviation will be I1 minus R1, 180 minus 2R2 plus theta minus R3. So this will be I1 plus theta minus R1 plus R2 plus 180 degrees. This deviation is asking delta dash and write it. Theta is what we should find out. We know all the values. So how to calculate theta? Mu sin R3 equal to mu W sin theta. Mu is 3 by 2. R3 value, R3 is how much? 30 degrees. Mu is 4 by 3 sin theta. So 9 by 16 equal to sin theta. This value of theta will substitute. So this will be net deviation. So I1 will be as usual 48.6 degrees theta. R1 plus R2 60 degrees. R2 plus R2 60 degrees plus 180. Okay, getting theta, substituting, so we'll get the deviation. I have sine inverse of 9, so net deviation will be, please check this, when prism immersed in water. The surrounding is the water. And this is silvered. And the complete problem, I'll show it. This is what we have discussed. See, you have to put effort. Nothing is there. You have to put effort. You have to draw the ray diagram first, then the geometry. Okay, afterwards, straight away, you can apply the Snell's law and some calculations. This should be the approach. I think almost this is a seventh problem. I'm showing it here. So the first page number one, page number two, the method is very important. A student must have a confidence the what will happen to the ray, how it will trace out. If you know the ray, how it moves inside the prism, then comes the geometry, then Snell's law. I think the methodology is somewhere here. If any surface is silvered, it will act like a mirror. The silvered surface will act like a mirror. Angle of incidence should be called angle of reflection. If it undergoes TIR also, the condition is same. But you can't write sine R2 is equal to 1 by mu. It's very important. Undergoes TIR, sine of R2 is equal to 1 by mu. Just a reflection, so you can't write, there's no relation between sine R2 and mu. I think some small things, please do make observation. Okay, we'll take the next one. This is something, one of the face of prism with a refracting angle, refracting angle. One of the face of prism with refracting angle of 30 degrees coated with silver. A ray incident on another face at angle of 45 degree is refracted and reflected from silver coated face and retraces its path. You should get even the diagram also. I think the problem demands student should draw the diagram. Okay, I have now. One of the face is silvered. Okay, this face will silver it. Huh? Then ray angle of prism 30 degrees at angle of 45 degrees. One of the rays incident at an angle of 45 degrees. Let me bring normal. Now it is a incident at an angle of 45 degrees. It will be incident normally and retraces path. It should be incident normally 90 degrees. This angle 45 degrees is asking to get the mu. This is R1. What is R2? R2 will be 0 here, no? And this angle of prism A. Sine I1, mu sine I1. Very simple problem over. So he's testing all about the how you draw the diagram. So this is very fundamental. Looking at this information, you should get the diagram. In the diagram, how that ray incident all has to be done. So these are some objective questions what you can expect in final exams. Questions of this kind where information is there, only literature. You should get the diagram. Then from the diagram, writing the equations. If you are interested, everything will manage. When you are not interested, then everything is difficult. That's what I feel. Now, one more again, I brought it. In an isosceles prism of angle 45 degree, it is found that when the angle of incidence is same as the prism angle, the emergent ray grazes the emergent surface. Find refractiveness of material of the prism. For what angle of incidence, the angle of deviation will be minimum. Something very grazes. You see that? Isosceles. Isosceles angle of prism, this angle. When the angle of incidence is same angle of prism, it grazes its telling. Let me draw this. This is a normal here. Okay, so we will I1, R1, R2. I think this must be 90 degrees. I2 90 degrees. Oh, I should do something with this. When it changes, so this is, let's write equation. Find the refractive index of material. The other medium surrounding the prism is air itself. So sin I1 sin I1 equal to mu sin R1. R1 plus R2 equal to A. Then sin R2 at other here at this point. Mu sin R2 should be called sine of 90 degrees. So therefore we'll get the value like this. Here is asking the mu of a prism. We know I1. I1 is 45 degrees, so this will be sine. And we have R1 plus R2. Where all sine R2 is there, I can write 1 by mu. So we need a value of sine R1. So I'll rewrite this R1 equal to 45 degrees minus R2. So sine R1 is equal to sine of sine 45 cos R2 minus cos 45 sine R2. Let's apply the sine of A minus B formula, expansion of this sine A cos B minus cos A sine B. So sine R1 equal to 1 by root 2. Cos R2 will be 1 minus, so further solving this, sine R1 1 by root 2. Sine square R2 will be root of, so sine R1 is equal to, substituting this mu sine. We have to calculate the refractive index of material, no? First we should calculate the sine R1. So mu sine r1 is equal to 1 by root 2, this is equation 1 equating 1 into 1 by root 2 equal to mu square minus 1 by root 2. Squaring on both sides. Okay, this is our answer. Again, getting the diagram, you have to draw a diagram, there's no other way. Hope by this time, I think it's you are understanding that what I'm insisting. Reading question, getting the diagram, then looking at the question, then how the ray moves, what conditions will have refraction, reflection, grazing incidence, grazing emergence, drawing the diagram. Then from geometry, some relationship between the angles. Then the Snell's law. And some conditions like a TIR. Here we have brought the conditions of TIR. Grazing emergence, no? So the idea of TR is what we have brought it here. One more very simple problem. The curve of angle of deviation versus angle of incidence I1 is as shown. Find the refractive index of metal of prism. We know it will not be symmetric. Oh, you can see this difference in angles. Huh? It's asking to calculate the this one mu of a prism. We know the deviation formula. Deviation I1 plus I2 minus A equal to 0. Minimum deviation, how much it is? 60 degrees. And we know mu equal to sine of A plus delta minimum all divided by 2. So minimum deviation we know. Angle of prism we don't know. If you know the angle of prism, then we can work out here. Then we know at minimum deviation, we know, and the angle is, so therefore A equal to 60 degree. Now substitute here, sine of 60 plus 60 by 2. What is this? I1 equal to I2. So I just replace this pattern. This is very important. At minimum deviation, the angle of incidence and angle of emergence will be equal. So therefore, this I2 will become I1. So once you know this I1, we'll get the angle of prism. Then substituting that everything in this formula. Okay, kids, we had some good number of problems is what I discussed here. See, the theory is something very easier. Anybody can teach Anybody can learn. I don't feel something like learning theory is something very big issue. Of course, you should know the theory, but you see the problems like so. Directly when you come to the problem, what all you know is there are the form, there are the information. It will become information. Each and every problem again you have to read the question, draw the diagram, write the equations, bring take help of some geometry and what all physics you know related to the ray optics that you have to apply Snell's law. So only by solving numericals, what will happen? You gain the knowledge, not like only just I'll read theory, I'll go. Competitive exam not possible. You can't become engineer. There's a primary thing. You want to become, yes, you have to solve the numericals. Almost every topic I'm insisting this one only like theory will come, then the numericals, then okay, teacher is helping you. Almost I think if you look at the total app or the website, we have almost 12,000 numericals are there. You take help of this further. Just only think on that. That is more than enough for almost all the competitive exams. You should have a patience, first of all. Like interest should be there. Like okay, let me learn, let me think and all. So don't bother about going wrong. So like I'll if I go wrong with the problem, let it be what is there. Even when you do wrong, you are going to learn a lot. Students should jump into the problem. That's all. There's no other way. So many students will tell like, sir, like a problem, solving problem very difficult. Yes, of course. What to do for this? Solve first lower level problems, then you gain confidence, you'll get an idea, then go for higher level. There's only method available. So you go to the any part of the world, you don't get any magic teacher who will teach and you'll solve problem. No. Even I thought so many problems. Huh? You go and start solving other problem. Again you find difficult. So this is very important. So don't think that teacher will help you to solve the problem. No, he'll just show you like see how in different situations this can be applied. At least with this you should grow. But just mere listening to my lectures and you don't solve any problem, again no benefit. You have to solve again the problems. Okay, fine. So your life, you have to put effort. Without effort, you want to gain the knowledge. This is not possible. Huh? This is a wrong concept. So many students, I see like they will listen some lecturer. Okay, as long as you are listening, okay, fine, good. You go open book and start solving. Nothing will be there. So insist on the type of videos where the emphasis more on the problems solving. And you must also work out more numericals. Then only I think competitive exams you can manage, I feel. Huh? Okay, I'll tomorrow's class. I'll bring few more problems on the prisms. Will discuss few more problems so that you'll gain more confidence. Okay, thank you all of you. Take care. See you. Bye.